This video will cover section 2.1. 2.1 is on rectangular coordinates. So at this point in this semester, this is when we're going to begin to look at graphing. And when we talk about rectangular coordinates, what we're referring to is the x and y axis. So remember, you have a coordinate system that's made up of, for our sake, two axes. The one that runs left to right, where the horizontal axis is the x-axis, and then the one that runs up and down or vertical is the y-axis. And within this axis, or within this coordinate plane is what we would call it, are coordinates. And so to get to any point within this coordinate system, I'm going to move left and right and up and down. So if I wanted to get to a point in the this quadrant, I would go right in a positive direction and then up in a positive direction. And so the first value in a coordinate in this quadrant would be x, and the second value in this quadrant would be y. In this quadrant we have negative x and positive y. Then we have negative x and negative y. And then we have x and a negative y. The point where the two axes cross is known as the origin. Alright, now, when we're graphing, we're going to be using this information moving left and right and up and down. The first thing we're going to look at is the distance and midpoint formula, and they're going to go along with, in the next section, when we talk about some circles. So the distance formula tells us the distance between 2 points in a coordinate system. Now, the coordinates, if I want to find the distance between them, if they run horizontally, then I can just subtract the x values like I've done here. The second x value minus the first x value, and that'll tell me how far it is between those 2 points. If I want to find the distance between 2 points that are separated horizontally, then I can just subtract the y values. y2 minus y1 will tell me how far apart they are, because they have the same x value, so that's not going to change. Just the y value changes. That'll tell me the distance. But sometimes there are points that are not horizontally apart or vertically apart, but they are diagonal. And I can't just count the distance between, or subtract the distance between one x value or one y value, so on and so forth. So I have to have some formula to use. Now, when you were in high school, maybe in geometry and other classes, you talked about the Pythagorean theorem when you were dealing with a right triangle. Alright, you remember you had A and B, and then the way that you found C was you said a squared plus b squared equals c squared. Okay, and so what we are trying to find is c. So if I want to know how long c is, or the distance of c, then remember I take its square root. The square root of a squared value would lead me to c, and that is where the distance formula comes from. Alright, it is the square root of a squared plus b squared, or the square root of c squared, however you want to look at it. But the way we're going to find it is we're not going to find the distance of the x's and the distance of the y's, and so we have the 2 points already. We're just going to drop them into the formula. So the distance formula says the square root of the x's squared. Let me say that again. Distance equals the square root of the difference in the x value squared plus the difference in the y value squared. And so we simply fill in our values. It does not matter which value you put as x2 and x1, as long as they are the x's. Same thing goes for the y's. It does not matter which y value you put first, as long as it is a y value. Okay, so let's look at a couple of examples here. I want to find the distance between these 2 points, between point P and between point Q. Now point P is located at 3, -5. That means we went 3 to the right and down 5, and it's located here. Alright, And then I want point Q is located at negative 2, 8. So negative 2, 8 is left 2, up, and then up 8. Alright, so point Q is up here. So I want to find the distance between these 2 points. So I'm going to fill those into the distance formula. Now you're going to need to know the distance formula for the test. It will not be given to you. Alright, so remember, it is the square root of my x's. Alright, so here are my x's, 3 and negative 2. Does not matter which one comes first. So we'll say 3 minus negative 2. We're going to square it. Plus the y. So here are my y's. So we'll say negative 5 minus 8. And we're going to square it. Alright, and then if you want to put that in your calculator, it should always come out to be a positive number because you're squaring it, so you should always get positive. So if I have 3 minus negative 2, that will become 3 plus 2, which is 5. And then negative 5 minus 8 is negative 13 squared. Alright, then 5 squared is 25, and 13 squared is 169. Now remember, when you put this in your calculator, if you put this is what the calculator sees. Alright, but we are actually, move that over so you can see what I'm writing, but we are actually wanting to square negative 13, so you have to make sure that you put it in the calculator in parentheses so that your calculator will say this, negative 13 times negative 13, to give you the correct answer of positive 169. Alright, then if I add those together, I'll get the square root of, let's see, what is that, 194. Alright, and if you put that in your calculator, you're going to get a decimal. So let's look at it here. Now let me show you that. If I do negative 13 squared, I get negative 169, but if I put that in parentheses and square it, I get a positive 169. So make sure you remember the difference there. Alright, so we have in our calculator 25 plus 169 is 194. Notice I get a decimal. Alright, so that means I should have a radical sign in my answer. Now I'm going to see, can I simplify this 194? So I'm going to take 194 and divide it by numbers that I know are perfect squares. You don't want to go over this number. So start at 13 squared. So I would say 194 divided by 13 squared. 194 divided by 12 squared. 194 divided by 11 squared. And I'm just going to keep doing that until I get to the end. Alright, or if I come across a number that works. Alright. Oops, that was the wrong thing. Let's try that again. Alright, and notice all of them gave me a decimal. So what that tells me is 194 is the simplest I can go. So that's going to be my answer. Remember, this is distance. Distance is always positive, just like when we talked about with absolute value. Alright, this is distance. You have to get a positive answer. There cannot be a negative under that square root. There should be a negative when you get your final answer. Okay, let's try the next one here. Alright, this one says to find the distance between points P, located at 8, 4, and point Q, located at 2, 7. So we're going to drop those into our formula. Alright, so it says take the x's and subtract them and square it. Then take the y's and subtract them and square it. Alright, so then 8 minus 2 would be 6, and 4 minus 7 is negative 3. That'll give me 36 plus 9 which will give me 45. Alright, and if I put that into my calculator, the square root of 45, right, notice I get a decimal. So if I start with this number right here, whatever it may be, in this case is 6, and I divide 45 by 6 squared, 5 squared, 4 squared, 3 squared, if I come up with any whole numbers, then it can be simplified. So let's try it. 45 divided by 6 squared. Nope, 45 divided by 5 squared. 45 divided by 4 squared. 45 divided by 3 squared. And I get 5. So that means we can simplify it. So I'm going to rewrite 45 as 3 squared times 5. And then when I take the square root, remember the square root cancels out those exponents, so I'm left with 3. Alright, which remember is also the same thing as 9. Okay, so the square root of 9 is 3, or the square root of 3 squared is 3. And then the 5 stays under. So then this would be my answer.